Hi guys! This is my first YouTube video, so I'm just gonna jump right into it. So our first question is about the work energy theorem. It is a worker lifts a 20-kilogram bucket of concrete from the ground up to the top of a 40-meter tall building. The bucket is initially at rest, but is traveling 2 meters per second when it reaches the top of the building. What is the minimum amount of work that the worker did in lifting the bucket? So some key information here. The bucket is 20 kilograms heavy. It's going up a 40-meter tall building. It's initially at rest, but 2 meters per second when it reaches the top. And then it wants to know the minimum amount of work the worker did in lifting the bucket. So, first of all, our distance is 40 meters, and this is on the vertical axis since it is going up the building. The mass is 20 kilograms. The initial velocity is 0 meters per second since at rest, and then the final velocity is 2 meters per second once it reaches the top. So the first thing we need to do is find the net force. And the net force is going to be a combination of the force done on the bucket by gravity plus the force of the acceleration from the person lifting the bucket. So the force done by gravity is always the mass times the gravity. And then the force of the acceleration is just going to be the normal sum of forces, mass times acceleration. So we got to use our information to find the acceleration, since it's our missing variable. So we'll use the equation, the final force squared equals the initial force squared, plus 2 acceleration times the change in time. Times the change in distance. So, first of all, we have our final velocity, it's 2 meters per second. Our initial is 0. We want our acceleration, and our change in distance is 40 meters. So if we rearrange this a little bit, we will just make acceleration equal to 2 squared on 2 times 40. So it's going to be 4 on 80, which is equal to 0.05 meters per second squared. So now that we have our acceleration, we could input it into our initial equation up here. So our force net is going to be equal the mass times gravity plus acceleration, if we just condense that a bit. And then our mass is 20 kilograms times gravity, which is normally 9.8 meters per second square, plus our acceleration, which is 0.05 meters per second square. Okay, so our force net is equal to 20 times 9.85. So it is all equal to 197 newtons. All good, but we need the work. So our work is going to equal the force times the distance. So it's actually force times distance cos theta, but our theta is 1 since it's just going in one direction. So it's going to be our force, which is 197 newtons, times our distance, which is 40, and then all that times cos of 0 degrees, which is going to be just 1. So it's actually just equal to 197 times 40. So if we put that all together, we have 7,880 joules of energy, which is also equal to almost 8 kilojoules. Approximately 8 kilojoules. Okay, all done. Perfect.